Okay, well, good afternoon. Thanks for attending our first session this afternoon. My name is Eric Ironside, and my colleague here is Gregory Christakis. We're both product engineers for the GeoEvent team. Today we're going to be providing an introduction to GeoEvent Server, which brings real-time data analytics to the ArcGIS Enterprise system. A quick show of hands, anybody here who's at least installed GeoEvent and maybe played around with the tutorials? Okay, about half of you there. Anybody gotten beyond the tutorials, actually done something in their work? Okay, 1 or 2, 3, 4, okay, good. This is intended to be an introduction, but there's other sessions later on. We'll point out when those are going to be, and so get started here. So the goal of the session is to provide a high-level overview of what capabilities GeoEvent brings to the ArcGIS Enterprise. It's to introduce the core concepts of GeoEvent for real-time data processing. And finally, we've thrown in a quick demo that will hopefully tie it all together for you. So we're going to take a quick look at what it means to perform analysis in real time by reviewing several of our processors and their capabilities. Before we do that, I'm going to take a second to briefly discuss the core capabilities of GeoEvent Server and what it means in the broader context. So when we're talking about real-time data, what do we mean? We generally break real-time data into 3 different categories. The first one is things that just happen. So you can think of crime, lightning, or tweets. They're just things that happen in time and space. The second thing is things that move. So this is more of the traditional real-time type data. So you're talking about AVL and vehicles, things with GPS. And then the final category are things that change, but don't necessarily move, but they still have a spatial component. So these are going to be things like stream gauges, smart meters, air quality sensors, weather gauges, that sort of thing. So all of these components have a spatial temporal aspect to them, and the streams can come in real time and be processed and worked on in real time, sometimes in great quantities and or great speeds. This is a quick scenario that illustrates the use case for real-time data. So we have a construction zone here. Each vehicle is equipped with a GPS sensor that periodically reports its location. Vehicle location is continuously updated on the map, as well as a breadcrumb trail of where the vehicle's been. When vehicles exit certain zones, then a routine notification is generated. And if a vehicle over on the right-hand side actually exits all of the zones, then an alert is generated, letting somebody know, hey, your dump truck's headed down the street, or your generator. So getting back to the key capabilities of GeoEvent, GeoEvent it brings 5 key capabilities to the enterprise. The first feature is the ability to ingest high volume and high velocity data. This data can come from, like I said, connected devices, sensors, the larger Internet of Things. High volume typically means that there's just a lot of data. So GeoEvent is geared towards processing that large amount of data. High velocity typically means that it's coming in very quickly. So typically when you have high velocity, you're also talking about high volume, but sometimes not. The second feature is the analytics of that streaming data. So this both refines and enriches the data. It allows us to identify patterns of interest on the fly as the data is flowing through the system. The third feature is it introduces a big data storage solution to support the volume of data being received, and it's one that can be scaled to support configurable retention settings. So we can look at things like, I want to save 6 months or 12 months worth of data. The fourth is to extend the visualization capabilities of ArcGIS through stream layers for live feeds, as well as dynamic aggregations and discrete features through enhanced map services that are coming from the big data store. And finally, the fifth feature is the ability to disseminate notifications back out into the environment. So we're looking at notifications and actuation back to devices in the field that will directly impact the environment in which those devices reside. And I forgot to click on my animations here. Okay. So We're going to take a quick look at each one of these features in more detail. So the first capability was ingesting data from a variety of data providers. So the typical ones for this are AVL type things, so things with GPS receivers that are moving around. We also have fixed sensor networks that are reporting via radio, cellular, or satellite networks. Weather sensors for temperature, humidity, pressure. We could have public safety, so we're looking for the nearest ambulance to an incident, or trying to call in first responders to something that might have happened. Or we might be worried about commercial operations, such as tracking smart meters, or identifying issues related to our assets in the field. So the first capability is to be able to bring all of that data in to GeoEvent and do something with it. So the second key capability, once the data is ingested into GeoEvent, is to do real-time data analytics on the data. So the first facet of real-time data analytics is filtering. When data events flow through the system in high volumes or velocities, it's typically desirable to be able to weed out the ones we want to work on and kind of ignore the rest of them. So filtering allows us to focus on specific data events and ignore others. So for example, we could configure a filter that would allow us to filter on the color attribute of these events so that we're only passing through the orange and the blue events and ignoring all the other colors. Filters in GeoEvent also allow us to test for spatial conditions. These spatial tests are performed against known geometries that are called Geo Fences. So in this specific case here, a polygon Geo Fence is being tested against points of interest. So the points here might be a moving vehicle or something like that. So as the points come into the system, they're tested against the Geo Fence for whether they're in or outside of that Geo Fence, or maybe entering and exiting. In this case, we've kept the ones that are inside of the Geo Fence. It's also important to notice that geofences don't necessarily have to be polygons. Geofences could be points, they could be lines. Sometimes it's a challenge to kind of think of geofences as non-polygon features, but that's certainly a way that that we tend to use them when we work on things. So it's GeoEvent supports also all of the spatial relationships that you would expect from a GIS. So we can do things like disjoint, crosses, intersects, inside, outside, enters, exits, that sort of thing. In addition to filters, so we're still talking about the key capability number 2 for analytics here. In addition to filters, processors allow data to be manipulated, enhanced, and transformed in order to discover patterns, relationships, and conditions within the data. So we have a couple dozen processors that provide key analytical capabilities out of the box. And if you're interested in getting more information on these capabilities, Gregory and I are going to be presenting real-time analytics later this afternoon at 5:30 today over in one of the conference rooms down that way. Just some quick examples of the processors that we have listed here. So the first one would be Field Calculator. This one's pretty straightforward. You're basically using the fields in the events or the attributes within the events that are going through to calculate some other value. So you might be adding an additional attribute to the event that's going through, or replacing one field with another field. So in this case, we're calculating a unique track ID based on the driver's ID and the vehicle ID. The second one would be the Fieldmapper. So the Fieldmapper allows you to manipulate the schema of an event by adding, dropping, or renaming fields. So in this example here, we have a larger schema. We're going to map a couple of those fields at the top and a couple of the ones in the middle into a new schema, and we're going to change the name of some of those fields. So we can also change the field types as well, so we can go from dates to longs, or integers to strings and stuff like that. The Fieldmapper by far is one of the most used processors that we have out there, because it's always best practice to put a Fieldmapper next to your outputs. The next one is the buffer creator. This one's a spatial operator that does what it says. It creates a buffer around an event. So if you have a point line or polygon, it'll buffer that geometry by a certain amount. and then it'll either replace or append that geometry to the event as it's going through. So you can think of this one like if you have a lightning strike and you want to create a 5-mile buffer around it to look for facilities that might be impacted, you could use the buffer to do that. So once you've analyzed your data, you'll most likely need some place to store it. So the third capability here is the ability to store that data from GeoEvent after it's been analyzed. The primary output included with GeoEvent will send data to standard Esri feature services. So it'll just store the data in traditional data stores such as your Enterprise geodatabase or the ArcGIS data store. A second alternative, there we go. A second alternative is provided for storing your data with the what we call a spatial temporal big data store. This is a component that's delivered and installed with the ArcGIS data store, and it adds the capability to store hosted data sets. The data tends to come in, if data tends to come in at high velocity or high volume, then the spatial temporal big data store is a good place to put that. In general, it's in an order of magnitude faster for storing the data than a traditional feature service. But even if the data is not coming in all that fast, the data can still stack up in time. So the spatial temporal is very good at storing large amounts of data as well. So a quick example, if you had data coming in at, let's say, 500 events per second, if you have 500 vehicles driving around reporting once a second their position, it would just take a 1 8-hour shift to accumulate close to 15 million events. So you can see where that data really starts to stack up pretty quickly when we're collecting the data pretty frequently. The spatial temporal big data store is a good option for storing these high volumes of data, and there are some additional advantages, as we'll see in the next key capability. So key capability number 4 is the visualization of real-time data. So GeoEvent supports, once again, the standard enterprise outputs visualization strategies, so map services, feature services. However, GeoEvent can help improve the visualization of high volume data by providing enhanced map and feature services for data sets stored in the spatial temporal big data store. So this animation here is going to show you that the points are going to stack up for a while. So you can just notice the switch there. It's switched from displaying individual points to aggregation on demand. So what it's doing here is it's basically got a threshold of the number of features that it's going to display, and once it gets above that threshold, it's going to switch to a binning strategy, which is going to show you the number of events that occur within that bin. So in this case, the bins are hexagons. The bins are configurable. They can set to display counts. They can be set to display statistical values such as the average, the min, max of different fields. So if you wanted to set it up to show the average speed of your vehicles across your service area, you could do that. Or average depths reported from a depth sounder or something like that, you could do that. Now, we may not always want to store the data before we visualize it. So in some cases, we just want to see the data on a map as quickly as we possibly can. So if we don't need to store it, then we can use what we call a stream service. So in this case, the stream service, what it does is it connects directly to a browser endpoint or an application endpoint, and it connects using what we call a WebSocket. So it's receiving data that's being pushed to it directly from GeoEvent. So the client visualization tool doesn't need to poll for the data. It receives updates every time those updates come through. And stream services can work very quickly and get a large amount of data onto the screen for users to see and to detect. Once again, it's not storing the data, so it's kind of bypassing the whole storage layer of things, and that allows it to be very quick in getting the data up on the map. If you're interested in a deeper dive on visualization, I would encourage you to come to the real-time visualization session later today at 4 p.m. Okay, so finally, the fifth capability is dissemination. So we've already seen that GeoEvent allows you to store the data in a geodatabase or visualize it as a stream service. But GeoEvent provides a host of other outputs that can be used to disseminate information. So for example, if we were interested in when a specific asset went outside of its service zone, we wouldn't want to sit there and watch the map all day and wait for it to go out and look for the little icon there that's warning us. We would want to set up an output that would send us a notification through an email or an SMS text or something like that that said, hey, this vehicle is outside of its zone, you need to do something quick. So we can use notifications like this, or actuation is another way to think of this, to affect things that are outside of the GeoEvent. So speaking of actuation here, GeoEvent is fundamentally RESTful. So both the inputs and the outputs can utilize REST interfaces to push or pull data. So GeoEvent can send data to external like IoT interfaces, and it allows them to communicate with external devices, such as controlling thermostats or something like that. Okay, so that covers all of the key functionalities of what GeoEvent does. This last slide here is really to give you an idea of what GeoEvent looks like in practice. So the first screen you see here is what we call the GeoEvent Monitor. And this is where you're going to monitor all of your inputs, your outputs, and your services. It's going to have counts on it and some other statistics on there that will allow you to figure out, are things running correctly, are they not running correctly, what's going on with your system. Clicking on either one of these would take you into, for example, the service here. So when we go into a GeoEvent service, you can see that it's got a number of different boxes. This is what you see is what you get kind of editor, much like the model builder from ArcMap. The green boxes are inputs, so this is the data source. The diamonds here, the yellow diamonds, are filters. So we're filtering the data based on certain attributes or spatial properties. The blue or the yellow squares, rectangles here are processors. So these are going to be doing things like field mapping or field calculator or something like that. And then finally, the blue rectangles are going to be outputs. So this is where you're going to be sending your data, whether it's a text message or a feature service or some other external service. And then finally, each one of these is backed by a number of properties and parameters that you can use to configure the components so that they do exactly what you need. And with that, I'm going to hand the presentation over to Gregory, who's going to be diving a bit deeper into each one of those components.
Thanks, Eric. All right, so we're going to shift gears here and take a look at what it means to work with real-time data. Eric went over all the various components. But now we're going to spend some time diving into what specifically exists as far as those components go, so that way it might become more clear how this relates to you and your workflows. So when it comes to working with real-time data, the first thing we usually start with when designing a GeoEvent service is our input. We refer to these as input connectors. And we have several out-of-the-box input connectors available the second that you install GeoEvent Server. For example, you could pull a map or feature service for data. So if you have somebody using, let's say, Collector, for example, out in the field and they're collecting data, we can pull the feature service that you're writing to in real time to then do some sort of analytics on it and output it. Additionally, we could subscribe to an external WebSocket to receive data in that format. So it doesn't necessarily need to be HTTP, POST, REST type interface. GeoEvent can also interact with its own system. So if we have, let's say, files like CSV files in a folder that we're updating programmatically, we could have GeoEvent watch those for changes and pull that data as well. There's several out of the box. These are just a couple listed here, but there's many more. As far as input connectors go, we do have our partner gallery. A lot of our partners worked closely with us to develop their own custom input connectors, allowing you to easily ingest data in whatever proprietary formats that they're working with. So that way you don't have to go through the effort of trying to create this on your own if you are working with some of these. So we definitely invite you to check it out if you're interested. And then as a team, we host our own gallery samples as well for some commonly used third-party sort of input connectors, such as Verizon Network Fleet or Waze. These are just some popular ones, but these exist as kind of sample connectors that you can go and import into your own GeoEvent, allowing you to hit the ground running out of the box. And if for whatever reason, if none of the out-of-the-box input connectors or sample connectors work, it is possible to create your own connectors through highly configurable components within GeoEvent Manager, or you can develop your own entirely using the GeoEvent SDK. And what I will say is that if you are interested in learning more about the GeoEvent SDK, there will be a session tomorrow where we go into that in a little bit more detail. So we brought our data in, we looked at the input connectors. The next question typically is, where am I sending that data to? So we have out-of-the-box input connectors as well. So as Eric kind of touched on a little bit before, we could add or update a feature service if we want to, or a map service. If we're using the spatiotemporal big data store to store large volumes or high velocity volume data, we can utilize those service types and their special rendering capabilities to write data out there as well. Eric had mentioned stream services too. We could, maybe we're not interested in storing the data. We can certainly just broadcast this out to the web map client and display that. But if we're not interested in displaying this on a web map, there's other types of output connectors that we could use as well. For example, let's say we aren't interested in visualizing anything. We can use GeoEvent in a messaging capacity to send out texts or emails based on conditions met. So there's not always going to be a geographical component to this, should you choose to go that route. And then likewise, we could use it as like a system of record. There's various output connectors that allow us to write to various files, such as like a JSON file, CSV, things of that sort. And again, these are just a couple, but there's many more that are included out of the box. And similar to our story with the input connectors, we do work with our partners to develop custom out-of-the-box output connectors, allowing you to write your data to these various sources, whether it's ActiveMQ, RabbitMQ, Twitter, whatever it might be. And similar to input connectors, you could also create your own output connectors using configurable components within GeoEvent Manager, or develop your own entirely using the GeoEvent SDK. Then we have the processors. This is really what allows us to do our analytics in real time. So these are the out-of-the-box processors that exist as of 10.6.1. There's a couple that perform some sort of geometric analytics, such as like the buffer creator creates a buffer around the feature. Convex hull creates, a polygon feature around the furthest extent of your features of interest. They're doing some sort of geometric operation. Additionally, we have processors that perform kind of an attribute-based analytics, such as like the field enricher. We might want to take data in and manipulate the values of that data in some way. So it's not necessarily geometry-based, it's more attribute-based. And then likewise, we have some processors that do a little bit of both. So one example would be like the incident detector, which again, we'll be going into a little bit more detail with the analytics presentation coming up after this one. But incident detector, we might be interested in seeing, when does my vehicle enter a geofence, or when is my vehicle going 85 miles an hour? The first one is geometry-based, the other one's attribute-based. We're excited to announce that at 10.7 coming out later this month, there's going to be 6 new processors listed here. These processors, I'm not going to go into them right now, but if you are interested, for those of you who've used GeoEvent especially, if you're interested in seeing what these look like, what they do, our analytics presentation later on today will demo some of these in much more detail. So we're always developing these. That's a key point there. There's also, like our input connectors and output connectors, there's sample add-on processors available out there on GitHub that a lot of our user base has created, as well as other groups within Esri have created through various projects. These have been made available to the public as samples. And similar to what we've discussed before, you could create your own processors using the SDK. So if any of this is of interest to you, we definitely recommend checking out that SDK session later on tomorrow. Another component of a GeoEvent service that's of equal importance is filtering. So we kind of have 2 different types of filters. We have attribute-based filters and spatial filters. So with attribute-based filters, we can set conditions to check for what we see here. So is the vehicle's speed equal to 80 miles an hour? Is the vehicle's speed greater than 80 miles an hour? We can filter for that type of information in order to pass those records through. And likewise, there's a spatial component to filtering as well. So is the vehicle inside the geofence? Did it enter the geofence? Did it exit the geofence? Those are just a couple examples of what we can configure using filters to kind of get rid of the data that we're not interested in and keep the data or pass through the data that we are interested in. I should mention that of the spatial filters, the very bottom there, enter and exit, those are stateful. Those are stateful spatial filters, meaning that GeoEvent is capable of monitoring these data, the data that's coming in real time to see when something has entered. So I guess a good way of explaining this is a truck can't enter a geofence unless we know the last known location of the truck being outside the geofence. So assuming that this data is coming in and GeoEvent is aware of the statefulness of that record, we can use these types of spatial filter conditions here to monitor for that. So it's not just if it's inside or outside, but we can monitor that record as it progresses and updates. It is important to note that you can configure these filters using tags and regular expressions. So the best way I like to explain tags is, let's say you have two different input sources tracking vehicles. We'll stick with that example. And in input source A, you have a field called speed. But input source B, tracking maybe a separate set of vehicles, you have that same type of field, but it's called miles per hour. They both mean the same thing, but they're called something different. So it wouldn't make sense to set up a filter, or two filters, I guess, one saying watch for speed, the other one saying watch for miles per hour. We can assign some sort of tag to both those fields so it treats them equally. So instead of watching for speed or miles per hour, we can say, let's assign a tag called, speed for both of them and watch for that, and it'll treat it as equal. And then, of course, filters support regular expressions as well, if that's something that you work with. The last component when it comes to designing a GeoEvent service, and is of also equal importance, is geofences. So geofences could either be points, lines, or polygons. Oftentimes we think of geofences as polygons. Naturally, it makes sense. However, we can treat these a little bit differently and have them be points and lines. And the demo later on will show a little bit of how this works, thinking about it a little bit differently. But we support all these geometry types for geofences. And we also have two kind of key different ways of working with geofences. We have static geofences and dynamic geofences. So static geofence is when we're pulling the data. Let's say we're pulling it from a feature service. We want to know, here's all our boundaries from this feature service. We could pull that in once, and it's good for that initial pull. It's not going to continuously update as that information updates. It's just retrieving it, and that's it. And we can do that with either a map service or a feature service. But we have the concept of dynamic geofences as well, where instead of just pulling that map service or feature service, or as seen here, stream service just once, we can set up a time rule so that way it says, let's pull it every 5 seconds or 10 seconds. And that allows us to kind of detect change within our geofences. I think a good example of this might be like a storm. If we're watching a storm move across, let's say, a state or the country, it doesn't do us any good to just pull that storm once and have a static cloud just kind of looming there. We want to get a continuous update of that feature as it shifts and moves and its geometry changes. So we can use dynamic geofences for that. And this is done using synchronization rules. So again, that's setting up that time interval. One key thing to point out about geofences is that we can categorize them using unique names as well as categories. So when we pull in data from a feature service, for example, and that has our geofences, we can give each geofence a unique name, and we could also group those together in a category so that way we can reference them appropriately. So going back to the storm example, we might have a couple different hurricanes going on at once. So in that layer, they might have different names. We can set that up to pull and distinguish those records based on their name. But we also, from that same data feed, might have other types of storms going on as well, such as tornadoes. So in that case, maybe we only are interested in the storms, and so we can create a category called storms or hurricanes, and then a separate one for tornadoes, and we can filter against that when we're working with spatial filters and geo fences. So that's a little bit more detail about those various components. Now we're going to switch gears here and take a look at a demo that kind of demonstrates these key capabilities in action. So in this demo, we're gonna look at the monitoring in real time of a group of task group members or field crew as they cover a particular area of interest. And as they traverse through the area that we're treating as geo fences, we'll see real-time updates regarding where they've cleared or visited or searched as opposed to areas that they haven't. And then additionally, we'll see a visual notification of when they leave the area entirely. And while we're not showing this necessarily within the demo, we can have some sort of email go out if they are leaving that area and going rogue. So let's take a look at this. So again, here we have our 3 task group members, and we can visualize their movement in real time. This by itself is immensely powerful from like an operations point of view, because we get insight into what's going on in real time. But as these task group members make their way through this area of interest, we can see that the zones they visit or clear experience an attribute or symbology change in the web map. So this visualizes the areas that they've covered and can be persisted in a database for maybe later review. Lastly, as our task group members exit the area, as we see in the northern portion there, we can display a separate notification showing that they had left the area and record that separately, maybe in another table, or maybe we're just interested in visualizing it here. And then should these exits of the area merit immediate attention, we can use GeoEvent Server to send out a message, maybe a text or someone from a managerial point of view to correct course. So illustrated here is one of the 2 GeoEvent services that was created to kind of power that demo or make that demo possible. Just to quickly recap though, the components that Eric mentioned before. In green, we have our input. That's the data coming in about where our task group member's location is. In blue, we have our outputs. So in this case, we're sending out an email or visualizing it via a stream service. That's what allows us to see it in the web map. And then we have our processors and filters in yellow. So this particular service performs 2 primary tasks. The first one, as shown in the box here, is essentially allowing us to not only visualize where they are in the map, but also obtain some sort of information on where they are within that zone. So for example, if they're inside any search zone as indicated with the top filter, we might want to pass that along to our geotagger processor to say, I want to update that record set with whatever zone it is they were in at that given point of time. So we're enhancing our data in real time, and then we can push that out to the stream service to have that extra attribute field. Likewise, if they're outside all the search zones as indicated by that bottom diamond there, we might use the field calculator to do an attribute change on the data to show that they had left the area. So these are just kind of 2 different processors to obtain or manipulate kind of data depending on what our needs are. But ultimately, we're pushing that data that's coming in and displaying it using a stream service. The second component is we're using the incident detector to monitor for when they exited the area altogether. So maybe this merits a little bit of extra attention from an operations point of view. We can open up the incident detector to say, when they leave, we want a notification to occur. So we can either send an email, as we see on the right with that email output, or we could just visualize in a separate service that little red triangle saying like, oh, that's the area that they had left from. Just to kind of show you a little bit of what the properties look like that made this possible. Here we're looking at that first filter for when they're inside any search zone. So this string we see in the box here essentially is showing, it's looking at the geometry field of the incoming task group, and it's detecting whether it's inside any search zone geofence. If it meets that condition, it's going to pass through. If not, we're going to drop that record. We then pass those records that meet that condition to the geotagger as seen here. And here's just a couple of the properties, but essentially we're looking to see if they're inside if their geometry is inside any of the search zones let's go ahead and update an existing field within the data set of whatever zone it is that they're in, or whatever geofence it is that they're in. This is the second service that made this possible, and this service is what's responsible for that dynamic change of those zones in the web map. So this, going back to what I was talking about a couple minutes ago of how geofences aren't necessarily polygons, they could be points. This is an example of that. So in this case, we're pulling each of those individual zones from the feature service that they're stored within, and all those zones have an attribute value by default of not cleared. When that data then gets pulled through, we're looking with the filter to see if the zone contains any task group members. So the task group member in this case is our geofence. They're those individual people moving around on the ground, those points, those are our geofences. So we're seeing if there's some sort of relationship between the two. Assuming that one of those points or the task group members or geofences, however you want to think about it, is inside one of those zones, we then use the field calculator to update that not cleared attribute to cleared. And then once we push that out to the stream service, that's how we see this symbology change in the web map from blue to orange. And again, just looking at the properties here, here we have the filter, so we're looking at the geometry field of the search zone and we're seeing if it contains any field workers. So we're kind of flipping things upside down a little bit when thinking about geofences. Assuming it meets that condition, the record gets passed on to the field calculator as seen here, and we're just using a simple expression of cleared to change the existing field name of status to cleared. And then with the web map being symbolized the way it is, we see those changes in real time. So that's it for the demo. Just going over some quick summary and resources. GeoEvent Server again is a functional server role, bringing real-time GIS capabilities to the ArcGIS Enterprise. Consists of the 5 key capabilities Eric had mentioned. Ingestion of the data, so bringing in data from various sources, feeds, sensors, things like that. We're then doing some sort of analytics to it to obtain information that's of interest to us. We can then store that data, and even though that wasn't done in the demo, we could potentially persist this somewhere should we choose to do so. We also have the visualization capabilities. In the case of the demo, we're using stream services to visualize this within the web map client. And then lastly, we can disseminate that information out, so send it out to something and actuate on it. So maybe we send out an email to someone, maybe we just display it in the web map, whatever the case. But these are kind of the 5 key capabilities of GeoEvent. Here's some resources. For those of you who maybe are just getting started with GeoEvent, we got our step-by-step tutorials. They're free to download from this link here. Very popular tutorial, highly recommend it. It's our introduction tutorial. It's split into 6 different modules. Can't recommend it enough. But we also have some smaller tutorials that go into some of these individual components we discussed in a bit more detail, such as stream services, maybe a little bit more information about the spatiotemporal big data store. We also have our blog and discussion forums on GeoNet. We definitely recommend that you check that out should you have any questions. And you can find the video recordings of these technical workshops here. And we recommend and definitely invite you to come and check out some of our later sessions. So we just went over the introduction, but after this at 4 o'clock today, we'll be doing a visualization presentation. That's going to be going more into stream services and the symbology and the types of things you could display with that, as well as big data store, map, and feature services, those bin aggregations that Eric had mentioned earlier. Eric and I will be presenting the analytics session where we'll be going into a little bit more detail about the processors themselves, especially the new ones that are coming out at 10.7. Got some pretty cool demos for that. And then tomorrow we got our best practice session. So maybe some of you have worked with GeoEvent before. This is a really good session to attend if you're looking to learn, best ways you can maybe enhance the performance of GeoEvent or the do's and don'ts. That's a good session. And then for those of you who are developers and you're interested in learning more about the GeoEvent SDK side, we have that presentation too. And of course, please take the survey if you get a chance. We're always looking for feedback with how we can improve. If this was useful information to you, and we're always looking for that. So please do take it if you get the chance. But now we'll go ahead and open this up for questions and feedback. So, yes, sir.
Yeah, I have two questions. The first one, you're defining your outputs, for example, like a feature putting out to a feature class. Can you use the alias to sync up for your inputs or field definitions?
Did you hear? I couldn't hear it quite well. Did you?
Yeah, I'm sorry, I didn't quite understand the question.
difficulty.
If you can come maybe to a microphone there. That would help.
Yeah, that mic might help. Sorry.
So yeah, the first question was.
I don't know if it's even working. Sorry about that. All right.
It's when you're defining your outputs, your field definitions for your outputs to a feature class. Can you use field aliases to sync them up for your inputs with your inputs?
So the question is, if you're using a feature service output with a defined schema, can you use aliases to sync them up with your inputs? I believe the answer to that is going to be that we would want to use a field mapper. So you would have a defined field or a GeoEvent definition for your input, which is your schema, your field names, your field types, and stuff like that. And you would have a defined definition for your output, which you can import from the feature service itself, so you know you've got all the right names and the types. And then between those two, you would put a field mapper that would allow you to map the input schema to the output schema, and that would ensure that all of the data that you send out has the correct schema for that output. And that is one of the best practices that you'll see tomorrow.
And the second question is, does GeoEvent work in a high availability and HA environment? Yeah.
The second question was, does GeoEvent work in HA environments, high availability? Yes. Yes, it does. You're welcome. Any other questions? Yes, sir.
I heard you mention best practices a couple times. Is there somewhere we can learn more about said best practices?
So the question was, is there some place to learn about the best practices for using GeoEvent? The first place I would start with that is the tutorials. So if you haven't gone through the tutorials, by all means, I recommend that you go all the way through those. They come with sample data, step-by-step instructions on what to do there. The second one would be to come to the best practices session tomorrow. Can you run back to the session slide? So it's tomorrow at 10:30 a.m. So that would be another good place to start.
Yeah.
And then the last place would be to look on the GeoNet at the GeoEvent blog. We're always posting more information there on questions that people supply and or best practices for things we've seen that people might need help with.
Do you guys have any posting on federating with your portal GeoEvent server? I've been running into problems doing that, working with support on it, but I was just curious if you had anything out there.
So the question was, is there any resources about federating Portal and how that relates to GeoEvent, right?
Federating your GeoEvent server with your
Federating it with Portal. Yeah, there's resources out there. What I could do is, if you'd like, I could give you those specific resources later. If you want to meet up, I could certainly give that to you. Yeah, no problem. We'll touch base.
I would say maybe to extrapolate a little bit on that. Most of the time you're going to want to federate your server, but there are certain situations where you would not want to or don't have to.
Right.
So most of the time I would say if you're not willing to jump through the hoop of federating, then maybe just don't do it. So sometimes you do have to federate, sometimes you don't have to, and so there's so it's a tricky road to navigate there.
Yeah, there's certain capabilities that are exposed when you federate as opposed to not federating. So yeah. Any other questions? No? Cool. Well, if there's any other questions that pop up, feel free to come by our booth in the expo. We're happy to answer your questions. Thanks, everybody.